Hey everyone, this week is week 4 and we're getting into the soil physics side. I had posted a video a couple weeks ago that would have really tied in well. I realized it didn't work out. So we're gonna show you that again. So we're talking about soil and how much water it can hold and pore space and all that kind of stuff. So this is critical to irrigation and I hope I can simplify it. I made my video with a bucket. My bucket is now dirty, but I'm not in the business of ruining more buckets. So we're gonna use it again, and hopefully y'all can understand this. So we're gonna be looking at a root zone, and this is gonna change depending on the crop. If you're gonna grow turf grass or if you're gonna grow alfalfa, you're gonna have a lot different of a root zone that you're monitoring that you really care about. So and on the study guide on the quiz, keep that in mind. All right, they might tell you about a 4-foot soil profile, but depending on what crop you're in, we're going to care about a certain specific amount. So watch for that. Anyways, I like to think of it kind of like a bucket, which is why I have the bucket here. So uh, in last week's homework, we were working on water holding capacity and where we would figure out inches per inch. So, like in my soil, whatever type it is, it can hold, say, zero point 0.1 inches per inch of soil. So now when we put that into the whole root zone, so like a lot of the homework, we break it up into feet, and it'll say like your crop is potatoes. So you care about a 2-foot root zone. And the top foot is whatever type soil texture. And then the next foot is this soil texture. And you go in the charts and you look up, okay, this, a loam texture holds 1.8 inches per foot or whatever it is. And then you add them together. So basically, we can figure out the max amount of water that can be held in that root zone. And so I look at it like a bucket. Okay, like you hold your water in your bucket. And basically at the bottom of our bucket, there's water that just can't even be used. That's our PWP for short, our permanent wilting point. Okay, you get under there, you can't use any of that water. That water is going to be, you're only extracting that if you're like baking it out of the soil, so it's not going to be useful to the plants. So when you hit that, everything is everything's dead down there. Okay, so that's not usually a whole ton of water. But what we care about is the water between our permanent wilting point and our field capacity. So that's our FC up there. And that's right at the top. That's the max amount of water that soil can hold on to. And in between the two, so that is that's our available water. Not real good at writing on buckets. You have to forgive me. Or sometimes they call that the plant available water. So we can use between permanent wiltings. We can't use below. We can only bake that water out. Plants can't get that out. And above field capacity, we have, well, I've already written on there, I wrote grav for gravitational water. So basically, if you're over irrigating, you get over your field capacity as just as well as this bucket is going to hold water is how well your field's going to hold water. It's not going to hold that extra water. So there's a couple things that can happen. It can drain. So we call that deep percolation if it's going out the bottom. If it's going out the bottom, it's probably taking nitrogen with it. That's our nitrogen leaching. If you're seeing like a lot of ponding on the top of your field, and so we have that gravitational water, of course, it's going to go as the slope goes. So we'll get surface movement. And so it might just relocate that water and probably take some topsoil and whatever nutrients are in that topsoil and relocate it in the field. Or if it leaves the field, that's where we call it runoff. So gravitational water, we don't want to be irrigating there. We want to be between our field capacity and our permanent wilting point. But more specifically, we usually set a threshold that we shoot for. And it's usually kind of around the halfway point. And that's our MAD, our maximum allowable depletion. And so the idea with that is as they've researched these crops, they realize, okay, we get under that and we're really, the plant's still alive, but it's stressed. It's using a lot of its energy for getting water instead of, putting on fruit or grain or flowers. And so usually there's this kind of threshold, and we'll say our maximum allowable depletion is, so if it's say 50%, and say between our permanent wilting and our field capacity, the whole plant available water, if it was 5 inches available, and we set our thing at 50%, our maximum allowable depletion at 50%, then we would let kind of this 2.5 inches of water be used. But once we get down to there, we're refilling, we're irrigating, we're bringing it back up. And it gets trickier. So if you say some crops have a maximum allowable depletion of 65%. And so what that means is is if in that root zone, I'm going to use a 10 inches for an easy number. So if your root zone can hold 10 inches of water, and your maximum allowable depletion or management allowable depletion, however you want to call it, if you set that at 65%, okay, that means we can use 6.5 inches before we're going to re-irrigate. And so there's 3.5 inches that's left in that soil that we don't get into that zone. We always have at least that 3.5 inches in the soil. And so that's a kind of a quick rundown of that. So again, we're what we care most about is the plant available water. That's between our permanent wilting, we're not using anything below, and up to our field capacity.